Hi, I'm Marco Aversa. I'm a research scientist at Dotphoton. Um, Here I'm presenting a work that we've done in collaborations with the University of Glasgow. And the main idea of this paper is that we are scaling up the resolution of a foundation generative model from the base resolution of 1K by 1K pixels up to gigapixel resolution on a single GPU without fine-tuning, neither training. So the main idea is like that our method is really flexible, so you can go from the base resolution to the resolution that you want with our pixel smith method, or you can go in a cascade way across the resolution. The difference between the two is that the cascade is more stable and gives rich more details in the image, while this one is faster. The main idea of pixelsmith is that you start from the stable diffusion output, so you generate an image with stable diffusion, and then you upscale this output to the resolution that you want to achieve. This upscaled image is gonna be blurred, but it's not important because we want to use this only as guidance for our generation. So we take this image, we encode it into the latent space, and then here we know the scheduler of the diffusion model, so we can just add noise on top of it. And this is gonna be, all these latent steps are gonna be the guidance for our generation. The way it works on a single GPU is that instead of working in the latent space, we're working on patches. And these patches are selected randomly across the latent. We are keeping track of the time step of each pixel in the latent such that we are not denoising twice the same area. And the guidance mechanism mainly consists in using the patch from the guiding image with the patch of the image that we are inferring. And then on these two, we're applying a Fourier transform and we're averaging the phases of these two. Averaging the phases gives you more control on it has information on the structural information of the image. So if you average the phases, you can keep the image consistent with the low resolution one. Once you average the phases, you can then apply your stable diffusion denoising step. And here is when you reach your details. We introduce also this slider. So on the left of the slider, we have the guidance mechanism. And while on the right of the slider, we leave the stable diffusion free to generate without any guidance. If you move the slider completely on the left, you have stable diffusion completely unguided. And so you're gonna have all the artifacts and applications, while if instead it's on the right, it's gonna be really close the generated image to the blurred one. But in the middle, we have a trade-off between the two, where we have an image consistent with the the low resolution one, but with the rich details. And what you can do with this, you can fix artifacts in stable diffusion generation, or you can, with this control on the slider, you can also have like a more generative approach and generate images at higher resolutions. The model is really efficient and can be parallelized. In that example, we just tried on a single GPU, but it can be scaled up really easily. And there are several examples on the website, so if you want to play with it, the code is available, so feel free to use, and thanks a lot.